September.
This is the story of numbers, types of numbers, a lot of examples, and their uses. So let's jump right in. A long time ago, man used his fingers or markings on bones for counting, and later devised various symbols or figures for each number. While in those times, man normally counted the animals he killed and ate. Several thousand years later, man is still counting, although mostly money. Counting comes naturally to us as something that goes 1, 2, 3, 4 and so on. Hence, such numbers are grouped as natural numbers with the symbol n. Well, you may be rich one day, but there are days when your flat broke.
Alright, so the first thing we're going to do, is to, we're going to write down that we have got the, what type of numbers did he talk about first? What was it called? You didn't hear? Need to go back and watch it again? Okay, everybody listening.
Counting comes naturally to us as something that goes 1, 2, 3, 4 and so on. Hence, such numbers are grouped as natural numbers with the symbol n.
Right, so what was the first type of numbers that we're dealing with?
Natural numbers.
Right, the natural numbers, okay. And the natural numbers are the ones that come naturally to us, as he said. So the numbers, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so what I'm going to do is, now I want you just to watch in a second and you can copy. So we're going to write down natural. Okay, and we said that those are the numbers 1, 2, 3, 4, 5, 6, 7, and so on. And we said that they have the letter n. Okay, so if you ever see an n like that, it means all the numbers that we count naturally. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, easy enough so far? Okay, and these little dots mean what? Yeah, it keeps going on forever and ever, okay? So those are our natural numbers, right? Listening up, here we go.
Well, you may be rich one day, but there are days when your flat broke with no money left. So when it comes to describing the notion of nothing, a number 0 was discovered. When we add the number 0 to the set of natural numbers, we get what is called as the whole numbers.
Alright, so the next set of numbers is the whole numbers, right? And we give them the letter W, okay? So what are the whole numbers? 0, 1, 2, 3, okay, and so on. 0, oops, 1, 2, 3, and so on. Okay. Wait, listening. Right, what do we notice about the whole numbers? What do they include? The whole numbers include? Yep, and what else? Now, what do they include? So we've got 0, but what else? Yep. No. 1, 2. And what are those numbers? They are the natural numbers. Okay, so the whole numbers are basically 0 plus the natural numbers. Okay, so we've got the natural numbers and then whole numbers. What type of numbers do you think are going to come after that? Yep, Oscar. Right, okay, so negative numbers, good. Let's have a look at that.
Symbol W. In most circumstances, these are the numbers we deal with. Nothing more, nothing less. Except, of course, certain situations prove this to be not true. For example, when you have to measure the depth of a ship below sea level, when the temperature drops to sub-zero under very chilly conditions, and of course, when you owe money to the bank. In all such cases, the numbers are called as negative numbers, which when clubbed together with the whole numbers, form a new group called integers, strangely denoted by the letter Z. The term integer, as a matter of fact, is derived from Latin word that means whole, intact, or entire. So far, so good.
Alright, so what was that last group called?
Integers.
Okay, integers. Okay, and the group of integers includes which numbers? Let's have hands up. Yep. What else? 0 and yeah, and the natural numbers. Good. Shh. So remember, what do these little dots mean? It goes on. So what type of number is negative 10? Okay, no, but using the words that we're using, what type of number is negative 10? It's an integer, right? Okay, so those are our integers. Now, what letter, hands up, do we use for integers? What letter, hands up? Go on, Oscar. Okay, yeah, we use the letter Z. Okay, it's a bit of a strange one, but we use the letter Z. So, N for natural, W for whole, Z for integers. What type of number is the number 3? Hands. I want hands, don't want people shouting out. I want everybody focused and concentrating. Yes, Kai. What? The number 3.
Oh.
Looking here at what we've got. What does it tell us? What type of number is the number 3? It's an integer, right, good. What else is it? Enrique. It's a natural number. What else is it? It's a whole number, right, good. What about the number negative 72? What type of number is that? Hands. Yes, Tyler. It's an integer, okay? Is it a whole number? It is not a whole number, okay? Is it a natural number?
No.
No, right, okay, good. What type of numbers do you think are going to come after that? Yes. So after integers, what type of number do you think we're going to have to include now? Right, decimals? You said it. Fractions, okay. So let's have a look at fractions and how we get to those.
However, there are situations when you are required to deal with parts of a whole, or fractions as they are called. For example, parts of a pizza, measuring height more accurately, in this case 1.5 meters, calculating the fraction of a difference in time in a very, very close race, specific measures of ingredients in a cake recipe, yum, and so on. So any and every number that you can practically think of in the real world, which can be denoted as a fraction or in a decimal form, constitute what is called as real numbers, expressed as the symbol R. Now take any integer, say -4. This number can be denoted as a fraction, namely -4 upon 1.
How else could we write the number -4 as a fraction? Yes, Tyler. Yep, good. So that's the example he gave. Can we give another example instead of -4 over 1? That's right. What other way could we write -4 as a fraction? Yeah, Kai. -4 over 3? No, that's a different number. That'll be -1 point something. Remember, what does the line mean in... Sorry? Not 0, no. What does the line mean in the decimal? It means dividing, right? So can you think of two numbers that when I divide them, I get -4? Go on, Kai. -16 and 4, right? -16 and -4 or +4? 4, okay, good. -16 divided by 4 is -4. Can anybody give me another one? Give me another two numbers that when I divide them, I get -4. Enrique. Yeah, -8 divided by 2. What about another one, Ryan? I get two numbers that when you divide them, you get -4 out. Or even, can you get 4? Well, that would give us 2. You help me out, Kai? -48 divided by 12, good. Oscar, did you have another one? No? Yeah. Well, -16 divided by... That would give us 8. -16 divided by 4. Okay, that would give us -4. Okay. So we're going to put down in our box... Yep.
-64 divided by 16. I mean...
Yes, that would work as well. Yeah.
Yeah.
Good. Right, so we've got real numbers. So this includes fractions. So for example, give me an example of a fraction. A half. Give me another example of a fraction, Oscar. 3/4. What about the number 2? Is that a fraction? Can it be written as a fraction though? How? 2/1. Okay, so that's okay. What about the number 1/3? That's a fraction. How could I write that as a decimal? Enrique?
0.333.
Right, good. 0.333 recurring. Okay, so 0.33, and that's recurring. Good. So any number that can be written as a fraction, okay, including all these numbers, these are all real numbers, okay? All right. Put a box around that. Okay, let's continue.
So all integers are real numbers too, as obviously are the whole numbers and the natural numbers as well. Here are some examples of real numbers on the number line. We have 3/2, which is 1.5, minus 1/3, which is 0.3333. Just keep repeating the decimal digits. The number 6, 18/5, etc., etc.
Sit up, Kai.
Now most of the real decimal numbers can be expressed in form of a ratio. What I mean by this is that the number can be written as a ratio of two integers. Of course, the denominator cannot be 0. For example, 0.4 can be written as the ratio 2/5. Minus 0.375 is minus 3/8. Also, 2.33, where the decimal 3 keeps repeating forever, can be expressed as 7/3. So the numbers that can be expressed as ratio of integers, where the decimals terminate or repeat, are called rational numbers. On the other hand, there are some numbers that are irrational, or...
Okay, so let's have a look at what he's talking about there with rational numbers, okay? So we'll get rid of this bit for the moment. Alright, so we were looking at rational numbers. Alright, so rational numbers, he said, we could write as a fractions, okay? So these are fractions, such as, we said, a half, 3/4, the number 2, because that can be written as 2/1. We could also have a third, which is just 0.3 recurring, as Enrique told us. So any kind of fractions, recurring decimals, decimals, these are all rational numbers. Doing very good with my drawing. And we said that all of these numbers together were called, we just said it earlier, these are all real numbers, okay? So that gives us the letter R. So any of these numbers, okay, these are all called real numbers, okay? Now, unfortunately, it doesn't end there, because we have some numbers that we can write as, not as fractions. I'm going to do these over here now. We've got numbers that we call irrational numbers. So irrational numbers are numbers that, well, what do you think? If rational numbers are numbers that can be written as fractions, what do you think irrational numbers are? Yeah, go ahead. Well, not necessarily decimals, because we said rational numbers also could be, you know, decimals. Yep. So rational numbers can be written as fractions. Irrational numbers, it can't be written as fractions. Can't be written as fractions. So, for example, they go on forever. Can anybody think of a number that goes on forever that you might have heard of already? Yep, Oscar? Pi, right, good. Pi is a number that goes on forever. It starts off with what? 3.1415, but that number actually goes on forever and ever and ever and ever. Does not stop, okay? Which means that it is an irrational number, okay? Any number that goes on forever is an irrational number. Can anybody, so some other ones that you might not know, we've got the square root of 2. The square root of 3. If I put these into my calculator, it'll bring up a decimal, but those numbers actually go on forever and ever and ever and never end, okay? That's the thing with irrational numbers, they never end. And also, they do not repeat, okay? And I'm going to put a box around this. Okay, now irrational numbers are still real numbers, that's why they're still in this big box. Okay, I'll let you copy in a second, I'll just play the rest of the video. So I'll put it back a bit.
On the other hand, there are some numbers that are irrational or not rational. Try dividing the circumference of a circle by its diameter. The answer reads something like, and it goes on and on forever. The calculation never terminates, nor shows any repeating pattern of any sort. This is the number pi, also written as 22 upon 7. But this ratio is just an approximation, not accurate. Another example of irrational number is the square root of 2, which is the length of the diagonal of a square of size 1 unit. This number also does not terminate, nor do its decimals repeat a certain pattern. Numbers like these are irrational numbers, which have many applications in the real world, by the way. Examples being calculating area or volume of shapes that involve a circle, encryption algorithms, deriving compound interests on loans by banks, etc., etc. So numbers that cannot be represented as ratio of integers and where decimals do not terminate nor show any repeating pattern are called irrational numbers. Both rational and irrational numbers form real numbers, as you can see here. And here for you folks is naturally the whole real picture of all types of numbers, which rationally speaking should help you in your maths assignments.
Alright, so if I just put that back, let's have a quick look. So we've got all these different types of numbers. We've got natural, whole, integers, rational, real, and irrational numbers. So rational numbers, okay? Rational numbers are numbers that can be written as, it's right there. That's it. Rational numbers can be written as, yeah, decimals are fractions, okay? Decimals that repeat or terminate, so stop, so like 0.5, that is a rational number, okay? Irrational numbers are numbers that never stop and can't be a fraction, cannot be written as a fraction, okay? So tell me, what type of number is the number 6? Okay, let's shout out some stuff. What type of number is the number 6? It's a natural number. What else? It's a whole number. What else? Good. What else?
Rational?
Is it a rational number?
Wait, no.
No? Can the number 6 be written as a fraction?
Yeah.
How?
Oh, well, yeah.
No? 6 over 1. So is the number 6 a rational number?
Yeah.
It is, right. Is the number 6 a real number?
Yeah.
Yes, right, good. Is it irrational?
No.
No. Okay, right. What about the number 1/2 or 0.5? Is the number 1/2 or 0.5? What type of number is that?
Rational.
It's rational. Good. What else? Right. Yep. What else? Anything else?
No.
No. Is it an integer?
No.
No, because it's a fraction, okay? Remember, integers are only negative numbers, 0 and positive numbers. Okay, what about the number 2/3? Tyler, paying attention. What about the number 2/3? Tyler, is the number 2/3 a natural number? Is it a whole number? Is it an integer? Is it a rational number? Is it a real number? Right, okay, remember, if it's a rational number, then it's a real number, okay? Is it an irrational number?
No. Oh.
No. Okay, good. What about the number, the square root of 2?
It's irrational.
It's irrational, okay. So if it's irrational, can it be natural, whole, or an integer? No, it can't be any of those things. Good. Right, so I'm going to leave that up for a second, okay? And I want you to do a quick sketch of it, write it down in your book, okay? So it's the same as what I was writing up, but except it's neater. So if you could get that copied, that would be great.